Good afternoon, everyone, and welcome to my presentation about how minimized vibrations can help to reduce noise and to make your HVAC unit even quieter. Let me start by introducing ourselves a little bit. My name is Thomas Marthe. I'm a product manager at Getzner Werkstoffe in Austria. And with me today is my colleague Alvin Friedrichs. He's field engineer and he will help me out with a little bit more the technical questions. And I guess we also need to introduce ourselves a little bit, our company, Getzner Werkstoffe. We are located in Bürs, it's in Vorarlberg, it's in the very western part of Austria, so close to the Swiss border. And this is where we have our headquarters, our material development, as well as our production of our materials. But of course, you will not only find us in Bürs, but also represented all over the world through own subsidiaries or sales partners. And this means that we can provide a worldwide service when it comes to vibration isolation based on 50 years of experience. And this experience actually comes from a wide range of applications, from railway, construction, so the vibration isolation of complete buildings, and also from industrial applications such as rolling stock, shipbuilding, or of course the heating, ventilation, and air conditioning system. And in the later, with a very strong focus lately on the positive effects of efficient compressor isolation on noise reduction. Speaking about noise, I think we all have been confronted with the challenges of noise in one or the other way, as a manufacturer, as an installer, or even as an end user of, for example, a heat pump or any other HVAC system. And this is actually not surprising because we are becoming more and more aware of noises and their influences on our daily lives. And to underline this, I brought the graph with me, published by the Federal Environment Agency of Germany about the development of potential conflict areas caused by heat pumps between 2014 and 2030. And as you can see that the conflict areas will increase significantly just by the number of heat pumps installed, and also by another trend that we need to consider when we talk about noise, and that's urbanization. That means that we are all moving closer together, not only closer to your neighbor, but also living spaces such as work, leisure, sport, production as well are also moving closer together. And this means that this in combination with the increasing noise awareness means that the topic of sound and noise is here to stay and will become even more important in the near future. So when we try to solve our problem for our customer, of course the first step is to take a good look at the primary airborne sound. So with hoods, fences, sound barriers, and so on, and we all know that there are already very sophisticated systems on the market. However, a reduction of the primary airborne sound may please your neighbor, but not necessarily solve the problem of this low frequent disturbing humming noise that drives your customer nuts. And the Federal Environment Agency actually comes to the conclusion that a major portion of the sound that reaches our ears originates from or is transmitted through vibrations. This means that we need to take a comprehensive look at noise reduction and also consider structure-borne noise as one important source. And this means, in turn, that vibration isolation plays an essential role in solving our problems or our customers' problem. Let's look very briefly at vibration isolation a little bit more from a technical side. The performance of a vibration damper is significantly influenced by the dynamic stiffness, and that in turn is again influenced by the spring and dampening properties. And with the formula here in the orange box, that's how you calculate the natural frequency of your bearing. So that's your F0. To determine the isolation performance the ratio actually between the excitation frequency and the natural frequency of the bearing, this F0, which I have learned, is important. And if this ratio is 1, the system is in the resonance range. That means that the vibrations that are coming from the machines are actually amplified, and that's of course the point you want to avoid in any case. The isolation starts at a ratio of √2, so around 1.41, and the dampening properties of the material again influence the course of the curve and also the effect in the resonance area. So when your machine moves through the resonance area, that's where the dampening properties play an important role. Now, let's assume you have a machine that runs at 25 Hertz. You have or it's decoupled with a bearing with a natural frequency of 20. That gives you a ratio of 1.25. So it's not in the resonance area anymore, but you still don't have or achieve an isolation effect. If you now change this bearing to one with a natural frequency of 10 Hertz, you get a ratio of 2.5 and already a very good isolation effect. I think the very interesting question here is what happens over time. So, for example, if your bearing embrittles, that means that the softener that is used diffuses, the bearing gets stiffer, the natural frequency of the bearing increases. Or the other side, you're using a speed control compressor inverter technology. That means that the excitation frequency is changing. As soon as this ratio changes, of course, you're moving up or down this line, and in the worst case, even to the resonance range. Therefore, the selection of the right machine bearing, and especially the right material, is the key to a long-term isolation effect and a long-term vibration isolation. To summarize it a little bit, a good vibration isolator shows a low natural frequency, is durable and consistent, and above all, shows a long-term efficient vibration isolation. So it doesn't brittle, doesn't get stiffer over time, nothing diffuses, and shows no dynamic stiffening under use, or the dynamic stiffness should be as low as possibly. And especially the last 2 points are very important and brings me to the advantages of polyurethane, so PUR as vibration isolation material. So polyurethane has the big advantage that it actually gets softer under dynamic use. And so that's how you achieve higher vibration isolation when it is actually needed. When the HVAC unit runs or when the compressor is running, that's when the material works best. And in addition, polyurethane works without any softener, so nothing can diffuse, nothing can embrittle. In short, you get a constant, long-term, efficient vibration isolation. And at Getzner Werkstoffe, we rely on our in-house developed and produced materials, polyurethane materials, Silomer, Silodyn, and Silodamp, as well as Silocraft. And in the 5th program range, it's called Isotop, we actually use these base materials, Silomer, Silodyn, Silodamp, and combine them with metal parts for an easy and convenient installation and assembly. Now, let's take a look at some concept products and solutions for polyurethane-based vibration isolation. When it comes to an HVAC unit, there are basically 2 principles to decouple such a unit. First one is to decouple the complete unit or certain components inside. And when we talk about heating ventilation, it's primarily the compressor, the beating heart of any system that's causing the noise, that's causing the vibrations from these machines. Both concepts have slightly different objectives. And as I mentioned in the beginning, we are specialists in vibration isolation. And that's what we do, that's exactly what we do in both cases. However, while the decoupling of the complete unit reduces primarily, I would say, structure-borne noise by preventing vibrations from being transmitted to the building structure, the vibration isolation of the compressor also has a very positive effect on the primary airborne noise. Why? Because the adjacent housing parts, everything that's around this compressor, is less excited and so produce less noise. So for both concepts, there are ready-to-use products available. So for the complete unit bearing, which is more, I would say, maybe more on the project side. And there are different products and solutions available which can be selected and calculated, matched to the customer's need. And of course, also for the compressor bearing, there are different products, ready-to-use products available. And we are also there to help you in the designing phase, in the selection of the right bearing, just to find the right product for you. And I guess the best starting point to learn more about these products is to visit our stand. It's just down the aisle in Hall 4, stand 312. So I would say it's enough for the moment. And I brought 2 examples with me to show you a little bit some results, some measurements we did. One on a complete unit bearing and as well one on the compressor bearing. This first example is actually a very typical case. A production needed to expand, but there was no space left, and there was only one room left above the office spaces, above the office space, and that's where the customer installed 3 chiller systems, 2 with 2 scroll compressor each. And as soon as the machines, the chillers were turned on, got the complaints from the staff that it didn't work. The structure-borne noise was too strong, and they couldn't concentrate, they couldn't work, and that we need to do something. At this time, there was a standard rubber metal element used, and we were asked to bring in our expertise and especially our material to solve the problem. And we did that with a point bearing, quite simple piece of material with Silodune, placed it underneath the machine, and then we were able to do some measurements. And in the first step, we were looking at the vibration reduction we would achieve with this Silodune point bearing. And as you can see, we reduced the vibrations by about 10.6 dB compared to the existing bearing. So what does that mean for the poor guys in the offices below? We succeeded in reducing the secondary airborne or the structure-borne noise between 3.5 if one system was running and of 6.6 dBA when all systems were in operation. And to summarize that a little bit, so 2.6 dB reduction in vibrations led to a reduction in structure-borne noise underneath the machine room in the offices below of 3.5 dBA and 6.6 dBA. Now, I also promised you measurement results from an isolation of compressors, and this is a little bit challenging. We had to challenge ourselves a little bit because the decoupling of a compressor is normally becoming part of the product concept of the OEM. It's an OEM business, and therefore OEMs are quite reluctant to share their measurements, especially to publish them. So we had to rely on our own laboratories, do our own measurements, and the challenge we put on ourselves was reduce the noise of this HVAC here on the left by only installing an efficient polyurethane vibration isolation. So we didn't change anything on the machine. We don't even have the experience to do that, but we only exchanged the vibration isolator underneath this reciprocating compressor. So how did we approach this challenge? Well, first we tried out to find the absolute sound levels with the existing rubber part in order to evaluate the starting point to get a comparison. Therefore, we started up the compressor, let it run through the operating frequency range from 30 to 70 hertz, slowly and continuously. And as you can see, we identified about 3 maximum peaks levels in dBA at 30 hertz, 56 hertz, and 69 hertz of the operating frequency of the compressor. After this first measurement, we changed to a polyurethane-based product from Getzner. It's called Isotope MSN-DEMP. It has a 37.5 millimeter Silodune core inside. And then we repeated the measurements dot for dot and looked at the reduction we would achieve, especially at the maximum peaks of 30, 56, and 69 hertz. And what we found is that, and that's the very interesting part, in these maximum peaks, we are able to reduce the primary airborne noise by over 7 dBA by only exchanging or using an efficient vibration isolation with Getzner polyurethane. And when we consider that compressors with inverter technology, speed control compressors, do exactly that they move through these operating frequency down to, I would say, down to 30 hertz, up to 70 hertz, stay at 50 hertz, and so on. I think it's fair to conclude that we need to consider efficient vibration isolation even more in order to keep the noise low. Now, if we go just one step deeper in our measurements at 30 hertz, so at the compressor operating frequency at 30 hertz, at the third octave spectrum, we also see that we see an improvement over the entire audible frequency range. So over the entire audible frequency range, that's where we see the improvement at the operating frequency at 30 hertz. And with this actually brand new measurement results and very promising results in mind, we can conclude and put everything in a nutshell. Quieter equipment. I think we achieve quieter equipment, or we can reduce sound level in primary and secondary airborne noise by either with a complete unit bearing or with even better, with a compressor bearing inside the unit. And of course, best of all, if you use a polyurethane material, the best, of course, will be a Getzner polyurethane material, Silomer, Silone, Silodemp, combined maybe in an isotope element. And to short, we achieve quieter equipment thanks to an efficient polyurethane vibration isolation from Getzner. That's my conclusion. And if you want to discuss vibration isolation in more detail or need some more answers or just want to chat, we are of course there for you. We are literally just down the aisle, as I said before, in Hall 4, stand 312. I thank you very much for your attention and enjoy the rest of your show.